Dun, dun, dun. Hello everyone, and welcome to another episode of Fun Angular Node-based JavaScript development with me, Mattias Johansson. Today we're gonna talk about... It's gonna be great. Let's get started. And I have a special guest with me today, Erik Rydeman, my Swedish friend.
Hello.
Who likes, I don't know what you like, making far less serious things like fun little games and stuff like that.
Indie stuffs. Alright, so this is kind of like a semi-vacation episode. It's Christmas and stuff, so let's not make a proper episode. Like just have some fun, some questions and answers.
That's right.
Yeah, so this is Erik. You might have watched the previous episode where we pair program on Erik's game.
Clone Drone in the Danger Zone.
And Erik is from Sweden as well as I, so it's home over Christmas, and we've spent the New Year's together, and we're basically just a bit hungover at the moment. And I guess, oh my god, I'm gonna make an episode, and can't we just answer some questions and answers together? And that's
I will answer all your questions about what the best Angular JS nodes are.
Yes, all the nodes.
The nodes and whatnot. I love your work. Happy New Year. Happy New Year to you too.
Yes!
But that's not a question.
That's not a question, but thank you, Mike. What do you think of FRP?
I have no idea what that is.
Functional Reactive Programming.
Oh, that's pretty cool. You could explain it to me as if I was a child who has never programmed functional reactive programming.
Functional reactive programming is basically the observable pattern, and then a lot of marketing.
Oh, yeah, that's a good pattern.
Yeah, so it's like... Yeah.
You dispatch an event.
Yep.
People listen to it.
Yep.
But they don't,
Yeah, exactly.
The dispatcher does not know who is listening to it, thereby creating a nice sort of flow of information.
Yeah. Oh, the observable pattern. It's... So you know the observable pattern. There is a thingy that you can subscribe to and can observe it.
Yes.
And functional reactive programming is that you stuff like a chain of functions after the observable. Like for instance, at the upper part, it might be like a function that points down to an observable, and so it's a chain that observes each other, so that the interface constantly reacts.
So basically, it's interesting that how you describe it. So basically, it sounds like there is something being observed, and I'm guessing. So one of the patterns that come up all the time is like Modelviewcontroller.
Yeah.
I hate this pattern, but it is useful.
We should talk about why you hate that later.
Well, in game programming.
Yeah.
But it's a useful pattern, I think, just for talking about, clarifying what you're talking about, like even if you don't use it.
Yeah.
For example, the thing that's often being observed in it is the model, right?
Yeah.
That's the thing where, that's where the data is, that's where the truth of what is happening, is based, and like a value changes or something like that, and then like it cascades to, the system reacting to it, right?
Yes.
So it sounds like what functional reacting or reactive programming is all about is part of the key kind of cool thing about it is it that you sort of data drive or specify in some sort of high level way how are you going to react to this observable change, or is that just
it's kind of like the promise of it is that you can program a lot more declaratively. Like there is state, and you just, depending on what the state looks like, I will render this.
I see.
So I think that I have this. I have a colleague Felipe that you met yesterday. He talks a lot about how people don't understand that the observable pattern is an optimization. It's not an architecture, because in game programming where you have in game programming, the way I understand it, and it's very much focused around the run loop,
that's not necessarily true. I think beginning programmers or beginning game programmers it's like, yeah, you have a run loop and you imagine it's just being like one big loop.
Yeah.
But that's not how you write a game nowadays.
Oh, interesting.
I mean, it's like you have, the same concept of, there's like an object, it starts, there's an update function. Like that's the loop part of it, I guess.
Yeah, exactly. It has the update function that runs all the time.
Oh, right. Yeah, but it's like there's a million objects and they each have their own update function. And of course they are executed after one another.
Yeah, but that's my point.
That's what you meant.
I understand that it's not like just one big rendering function in like
the main
but like in JavaScript there's a DOM. Right? It's like an object that you mutate. So it's not like you have an update. You often don't have an update function that does not exist. But it's kind of like, oh, this happens, then I change this field.
Yeah.
Like,
so I see. So the reactive part here is that you change something and it cascades in, stuff reacts to it and other things happen as a result.
Exactly, and the function is the functional part of it is that it's just pure functions.
Right.
So it gets in a state and it renders an output all the time. So it doesn't really mutate anything. It always given a state.
Oh, the state changes, and this is like just how we're presenting the change.
Exactly. So it's sort of like it is sort of like an update function.
So in your reactive functions, though. Can those functions make changes to the underlying state, or is that frowned upon?
That's frowned upon.
I see.
That makes it that will break the entire point of the pattern. But
got it.
But the thing is, the observable at the end, the point of an observable is that it only dispatches unchanged when it actually is changed.
Right, and it doesn't know about the rest of the system.
Yeah.
Like for me, I use the observable observable pattern all the time in game programming as well.
Yeah.
But I mean, a lot of the time, the main benefit is that you can have the observable not know about, say you have a health bar, for example.
Yeah.
And you have a player, and the player has health, and when the health changes, the health bar goes down. A bad thing to say would be to say in the player code, health changed, find the health bar and change it.
Yeah.
That would be terrible. It's better to be like, hey, everyone, my health changed.
Yes.
I'm a character. And then the health bar is like, oh, someone's health changed. It was the player. I'm going to update myself.
Yeah.
But the health bar doesn't have to be there. If it's not there, there's no null pointer exception or some bullshit like that.
Yeah, it's a broadcast.
Right, exactly.
Instead of telling things.
Yeah, and that way you can, everything is separated and you can write really
that's nice, but that is I get that. That is awesome, but I don't think that is a trait of the observer per se. It's that is just you creating a broadcast, so to speak.
Well, I mean,
the observer, the point of the observer is that it only dispatches changes when it's actually changed. For instance, say you could implement that pattern by just updating the state. The health. I just update the health here, and then anybody who is interested can just look at that health.
Right.
It doesn't you could then have just this update function that runs every frame or whatnot, and then just looking at that and updating.
Right.
The problem is that is extremely expensive to do that sometimes. And then you add the observable in order to get that to only be rendered when the state has actually been changed.
Right.
And this is very popular in JavaScript and web applications specifically because mutating the DOM is expensive. A lot more expensive than just pushing things to OpenGL in game programming. But I think that there's a misconception among programmers that the observable is an architectural pattern.
Maybe this is getting into semantics, but what do you mean by an architectural pattern? What is the difference between a pattern that is an architectural pattern and a pattern that is just, I don't know, some sort of hobo pattern?
I think that a lot of people have the misconception that the observable pattern structures your code. But it's not like the structure is like that's separate from the observable. The observable is there in order to optimize your code and make it faster, so that you don't run code unnecessarily.
It's interesting. I think that maybe it's fair to say that it being faster is one benefit of using this pattern. But I imagine that, like as I mentioned earlier, another benefit is that you're essentially decoupling the observer from the observable. Like, or rather, you're decoupling the observable from the observer.
Sure. Like,
So I don't think it is wrong to say that either of those things are true.
Yeah.
But as with any programming pattern, if you think that using it will automatically make your code beautiful, then you are a beginner and you should think more about software architecture.
Sure. Yeah, sure. Like the point is, like, the observable pattern might lead to you decoupling your code, or like decoupling the knowledge about the rendering, and that is great. But I think that the primary, like, you can achieve that without the observable pattern.
Absolutely.
Yeah, it's the specificity about it being that you can observe and get the change whenever that is changed.
Right.
That exists only for performance reasons, that specific part.
So this is really interesting because I don't do much JavaScript, but I still know this pattern, the observable pattern.
This is,
And it sounds like in the realm of JavaScript, the main benefit, the overwhelming benefit is performance. But I think if you bring up like the Gang of Four kind of patterns in software architecture,
I think the observable pattern is from the Gang of Four.
Right. I think so. Like it is a component of Modelviewcontroller. It's like a sub pattern of that pattern. So it's like a very well known pattern.
Yeah.
Yeah, like it's part. The view observes the model.
Yeah. Okay. Fair.
Pretty much. That's how I was taught it anyway.
Yep.
And you can argue. That's beside the point.
No, but I think you're right.
But yeah. One of the main kind of things I find interesting about software development is that these patterns that you have they have advantages and disadvantages. And it sounds like in the realm of JavaScript, the main benefit is performance. In the realm of game programming, it's a small performance gain, sure, but it's not that expensive on update to just look at the model. You have like a pointer to the model. It's like an integer or something. You can just look at it. It's not that expensive to read it and have an if statement that says if it is something or other, It's not that bad. It's more like the benefit in game programming is more about decoupling the code. But I can imagine there's probably another realm of software development. I don't know, medical robot programming or something where the observable pattern is maybe it has some other benefit or drawback that makes them use it or not. Like, a heartbeat monitor might use it, for example. I have no idea what that would look like because I don't do that. But my overall point is that it is always a risky move to declare that a pattern is like primarily centered around one benefit.
Because it might be like depending on the context, the one benefit might overshadow another benefit, and the focus might lie elsewhere.
Yeah, and I'm not going to go into a rant right now, but some of the worst code bases that I've seen professionally in the game industry, they're really over-architected ones. They tend to come into existence because people focus on the benefit of some pattern. But then they fail to consider the context or the knock-on effects of using this pattern and deriving this benefit. Modelviewcontroller is a good example. It is often, it has benefits, separates concerns, changes the logic, maybe it's good for performance, but it also makes it harder to write, small, simple, primarily like graphics or physics interactive classes in a beautiful sort of straightforward way. So it ends up being slower to do that and ultimately probably not the best idea. But again, it depends on the context. Sometimes it is the best idea, sometimes it's not.
I want to make a tangent to the fact that this is a generic pattern. Even though we are completely different programmers, we can still reason about this pattern. We have all different dialects and viewpoints of the pattern, but we still both know the pattern.
Yeah, we still both use the pattern.
Yeah, and there was this other question about